Okay, good morning and welcome back, everyone. Few things that we want to do here. First of all, I want to say almost all of you finished your syllabus quiz that was supposed to be due today, right? If you didn't finish that, be sure to do that as soon as possible. It's still available on Blackboard, so you can still finish it. I'll probably take it down, tomorrow or something like that. How come that just shut off on us? Okay, better. The other thing is, seriously? This is really going to put a crimp on today's class if this doesn't work. Okay, let's see what's going on here. Holy cow. All or most of you, don't breathe on the cable. All or most of you either started or finished that one practice math exam on that My Open Math. Remember, there's 5 questions and you can try it over and over again. Some of you might have even got flagged by Starfish for having a low grade. Yeah. Don't worry about it. Okay, Starfish is acting up right now, according to our Director of Academic Services. The way Starfish works, for those of you that don't know this, instructors can manually flag a student, okay? Colby misses 5 classes in a row. Jamie goes into Starfish and puts up a red flag and says, Colby's missed 5 classes in a row. And then that red flag goes to your coach and your advisor and the learning center and everything else. So that's a manual thing. Or I could say I can do green flags too. Kudos, Charisma's doing a fantastic job in class. I can do that too. Okay? The other thing it does is it automatically talks to the Blackboard Grade Center. And I have it talking to your percentage score. And if your percentage is below like 60% or 65%, I don't know what the default is. But if your percentage drops below that, it automatically flags you. Okay? Well, if you guys opened up that quiz, it was a 5-point quiz, right? And you did like the first question, and then you're like, I'll finish this later. It's now showing that you have a 1 out of 5, right? Which is a 20%, so then Starfish thinks you're failing this class. Okay, don't worry about it if that happens. Now, if it flags you 6 weeks from now, then yeah, your percentage probably legitimately is too low. Does that make sense? But for now, you shouldn't have to worry about it. So if you got that flag, don't worry about it. Okay, let's hope this keeps working here. So, couple things that I want to do today. If we pull up, my goodness, syllabus and schedule. If I pull up the syllabus, or I'm sorry, the schedule. I know why it's doing that. I think it's because this camera is on. Let's see if that fixes it. Like I said, I am updating this as we go. So I changed today's line. After Labor Day, a lot of this is going to change. So just kind of ignore it for now, okay? So what are we going to do today? I'm going to tell you a little bit about what we're going to do in this class, and we're going to spend the rest of the time practicing that Geogebra software that you guys all downloaded on Wednesday, okay? So what I'm going to do is, underneath course docs and links, you can follow along on the screen, or you can open this on your computer if you want. I just have a little intro PowerPoint that I'm going to show you guys here, so we'll run through that quick. Maybe. Okay, so what are we going to do in this class? Let's talk a little bit about that. I'm going to preach at you a little bit here. So there's this guy, and his name is Conrad Wolfram. And him and his brother created this computer software called Wolfram Alpha. You guys heard of that before? It's like this super duper math, computer algebra system, graphing, blah, blah, blah. It can do like the heaviest math equations, and it's just this really awesome piece of software that'll solve all these equations and all this kind of stuff. So he's a math guy and he's a computer guy, okay? And he gave a TED Talk one time, a video that I watched, and he talks about the 4 steps of doing mathematics. And there you can see the 4 steps that he identifies. Number 1, you got to define some problem or identify some question or problem that you're trying to fix. We're gonna try to unplug and replug. Let's try this. Bear with me. This worked perfectly fine the rest of the morning. I don't know why it's not working right now. Okay. So here's what Conrad said. He said we need to identify some question or problem. Step 2, take some mathematical model or equation or formula or something and apply it to the situation that we're trying to solve or trying to figure out. Step number 3 is to actually compute or solve that problem. Solve for X, do some arithmetic, pull out a calculator, some kind of computation, right? And then step number 4 is you take that solution, you go back to the original question or problem, you apply it back and you see if it worked. Did it solve our problem? Does the answer make sense? Stuff like that. If that's the full cycle of doing mathematics, Conrad argues that in school, elementary school, high school, college, he argues that in math class we spend 80% of our time on step number 3. So step 3 really dominates the time, right? He also argues that when we spend so much time in math class on computing and solving that we often are doing it by hand, paper and pencil, solve for X, right? You guys, if you've taken algebra class, you might think that algebra class is a lot of solving equations. The teacher gives you an equation, you solve for X and you give it back and then you get a grade on your homework or your quiz or something like that. So do we do some solving equations in math? Of course we do. Is that all of what doing math is? No. According to Conrad, that's only one step of the whole cycle, right? So yes, we still want to be able to compute, we still want to be able to solve. There's plenty of things that we want to be able to do by hand with paper and pencil. There's also plenty of things that computers and calculators and spreadsheets can do for us very, very quickly and more accurately than we can do with our own paper and pencil. Do you guys agree with that? Right? So I want you to be able to think of this doing mathematics as this full 4-step thing, not just the solving part. Okay? We want to have a more holistic view of that. And when appropriate, we are going to use computers and calculators to help us with some of the computation. Okay? So whenever I give that kind of spiel, I often think of this, maybe some of you have seen this before. Like, I just want to give this math student an A for being clever. Now, we know that's not what they're supposed to be doing, right? But that would be a clever math student saying, oh, here it is. So let me show you this. This is from your syllabus. Math 107 aligns to the following VCSU GELO, General Education Learning Outcome. It's called quantitative literacy. Notice the words that are in quantitative literacy: number sense, mathematical understanding, problem solving, logic, analytical thinking, construct and communicate viable arguments. Notice nowhere in there does it state student will be able to solve equations, right? Solving equations is just one small snippet of everything that we're trying to do. See how this is a bigger, grander view of what we mean when we say quantitative literacy? Take a look at the posters that I have up above the whiteboard, standards 1 through 8. These are your North Dakota K-12 mathematical practices. Maybe some of you even remember these from high school if your teacher focused on them. Look at number 1. Make sense of a problem and persevere in solving it. That's an extremely important standard that we want all math students to be able to do. Reason abstractly and quantitatively. Quantitatively means you reason with numbers. Abstractly means, how about we, instead of calling it a number, we use variable and we call it x. All right, that's what we do in algebra, right? We work with variables. Construct viable arguments. I already said that one. Model with mathematics. We're going to do that today here. Use tools strategically. Tools. A tool might be your pencil. It might be a straight edge. It might be a protractor or a compass. It might be GeoGebra. It might be Microsoft Excel. It might be a graphing calculator, right? Those are all tools. Attend to precision. Look for structure and look for repeated reasoning. Those are the skills that you want to be able to do. I saw this poster in a high school math classroom 7-8 years ago, and I took a picture of it with my phone because I thought it was a really good poster. It says step-by-step logic is more important than memorizing. You need to be able to think your way through a problem as opposed to just memorizing the steps to complete a problem. Here's the problem with memorization. You can run into millions and billions of different math scenarios that require thinking, persevering through the problem. It would be impossible to model every single one of those scenarios and then memorize all the steps that go with those scenarios. Heck, half of the scenarios you're going to encounter are like problems that don't even exist yet and people haven't even thought of putting into a math textbook yet, right? So I'm not saying memorizing is bad. There's certain things that we do want to memorize, right? 7 times 5 is? 35. Thank you. If you don't have that memorized, you're in trouble, right? But we learned that in elementary school that certain things we want to be super fast at and memorizing. But other things that get super complicated, you start to memorize too much, your brain fills up with too many things to memorize, and then pretty soon math just feels like this constant step memorizing yuckiness, right? We want to just be able to think our way through something logically. So that's what I think of when I see that poster. Now, here's your course description for Precalculus. Notice I highlighted equations and inequalities. We are going to do equation solving in here. In fact, that's that whole algebra chapter 2 that I've been talking about. Primarily, we're going to be solving equations over the next 7 or 8 days. And looking at different ways to solve. We're going to do some electronically. We're going to do some by hand. But that's only a small part of the course. The rest of it is going to focus on functions and graphs of functions. And this is called Precalculus for a reason, because a lot of you, if not all of you, are going to take calculus class after this. If you're a fish and wildlife major, calculus is coming, right? If you're a health science major, I think calc is either required or it's elective. Somebody help me out there. Is it required? I don't know. I know it is for fish and wildlife. Okay. Medical laboratory science. I don't think calculus is required. I think it's an option. But anyways, you're in Precalculus because this is supposed to be getting you ready for calculus class. Okay? Okay, here's what we're going to do. Man, I would like you to open up your Geogebra and open up your Blackboard. I'm going to shut this down and try to start over and see if this gets any better. Okay. Okay. This around. Did everybody get the Geogebra successfully downloaded to their computer now? And can you find it on your computer? Do you know how to open it? Again, I pinned mine down to the taskbar. So when I open it, Doesn't sound very healthy, does it? Oh, here it comes. Maybe. Oh, except it has the wrong picture. The bulb dying. There's the family. Let's try this. Okay. If you have your Geogebra open, it should look like this, right? I always go underneath options and I make the font size bigger, mostly for you guys for being on the screen, but if you're happy with your font size, don't worry about that. What I would like to do is I'm going to practice just a few things with this software, okay? So if you have your screen up here, you notice here's your graphing screen. Any line or equation or dots, this is your algebra window over here. It'll show it over here. Just go ahead and plot a few dots. That's our first tool there. See the blue A? So if you want to plot some points on the XY coordinate plane, click there, click there, click there. You can plot points, right? If you want to plot a specific point, like some number, comma number, if you go down to your input bar, like let's say I wanted to plot the point 5, 1. So I go parentheses open, 5, 1, enter. And notice I plotted exactly 5, 1 instead of trying to get my cursor right on the point 5, 1 and clicking on it, right? Everybody able to make a few points? Okay, one thing I'm going to show you here is I'm going to delete these points. I'm going to show you kind of a quick, easy way to plot lots of points at once if you already have the data stored somewhere. And I did that. I just made this up. If you go to your course docs and links on Blackboard, do you see that Excel spreadsheet called Geogebra Practice Data? Go ahead and open that spreadsheet up. And it should look like mine when it opens up. Okay. And it looks like we have column A and column B, and there's 21 of them. Do you guys see that? What these are going to be is these are going to be points, XY coordinates. So column A is all the X's, column B is all the Y's. So this would be 6, 85, 5, 87, 14, 65, right? I want to plot all those points, but I don't want to have to do each one individually, typing it into my GeoGebra. I'm going to show you kind of a copy-paste faster way of doing this, okay? So what I want you to do is I want you to highlight all of those cells on Excel and hit copy. We're going to copy it from Excel and we're going to copy it into GeoGebra, okay? So now go back to your GeoGebra and underneath View, I want you to click on Spreadsheet and it should open up a spreadsheet off to the side. Mine opens up on the right. Depending on how you have your windows configured, and I know Mac is a little different, it might open in a different spot. Did it open?
Mine's the same.
Yeah, the same. So GeoGebra has its own spreadsheet, columns and rows. So now what I'm going to do is I'm going to go into that first cell, that A1. I'm going to hit Control V, and I just pasted everything from my Excel into my GeoGebra. Were you guys able to do it? All right. And now what I'm going to do, and I'll come around and help you if you have any trouble here. Now I'm done with my Excel. Now I'm going to highlight all of my data over in my spreadsheet, and there's 21 of them. And when I have it all highlighted, I'm going to right click and I'm going to create list of points. I'm creating a list of points. And when you do that, it should spit them all out on this algebra window, A, B, C, D, E, F. Okay? Create list of points. There it is. And now I'm done with my spreadsheet, so I'm going to close it. I'm just going to X out of it. And now I just plotted all those points at once without typing each one of them in individually. It's kind of a nice little copy and paste tool. Now, I got all my points plotted, yet I don't see any of them on my screen. Why? Yeah, they're further up and further over and whatnot. If you look, all the y values are like 85, 87, 65, 64, 73, blah, blah, blah. Well, I'm only going to 6, so I can't see it, right? So zooming, there's a couple different ways that you can zoom. You can zoom in and out like the whole thing, both X and Y, zoom in, zoom out, zoom in, zoom out. Or you can just zoom one axis at a time, which is really, really useful. So grab your crosshairs button. This is your crosshairs, okay? And then hover over, well, first thing I'm going to do is I'm going to just drag. I'm only interested in the first quadrant. This is quadrant 1, 2, 3, and 4. All my numbers are positive numbers. There's no negatives. So I'm going to put my origin down in the left-hand corner because I don't care about the other 3 quadrants. I'm only interested in quadrant number 1, right? And then if you hover over one axis at a time, like I'll hover over the y-axis, see that little double arrow? If I click and hold, I can shrink the y or stretch the y, and notice x isn't changing at all. I'm only changing one axis at a time. Just changing the view. So if I scrunch it down, there's all my dots, right? Now I can go over to x, and I can stretch x or I can scrunch x, okay? So I want to have a user-friendly view, right? Like this is an awful scatter plot. That tells me nothing. That's just gibberish, right? But if I go like this just makes me feel better. Much better. I can see all my points, right? Here's another example of an awful scatter plot. That just looks like every dot is at the same height. Well, that's because I've scrunched it down to 35,000, right? I need to go like this. I think the highest value is Q. Q is all the way up at 100 there. And I think the lowest value is G. And then some of them go from 0, and I think the highest X value is 22. So I think I have all of my dots. So you should get a picture that looks something like mine. I'll walk around and check you out, see how you're doing. So you're going to want to do that thing where you can just zoom one axis at a time, right? Because so instead of using the zoom in, zoom out, just get it to double arrow it. Yeah, like that. Okay, now you're going the wrong direction though. We only want to see 0 to 100. So stretch, go lower and stretch up. There, keep stretching, but start lower so you don't run out of screen. Stretch up until you can only see like to 100. You're still at 2,000, so you have a long ways to go. And then for your X's, you're going from 0 to 24,000. You only need to go from 0 to 23. Hover over it. Okay, your axis is not visible. You got to be able to see your x-axis. There it is right there. When you hover over it, see the double arrow? Mm-hmm. Oh, wait, that didn't work. It should show double arrow when you hover over it. There, right there. Okay. Double arrow is when you can do the shrinking and scrunching. Go to View, and then select Spreadsheet, and then there it is. Yep. Okay. So we have our data set up there, and all I want you to do is be able to view a viewing window that is comfortable so you can actually see it. And especially if you're going to turn in a project to me, okay, you should make it visually friendly for the person who is opening it up and looking at it, okay? So notice that our scatter plot here, it doesn't have any labels on it. Like these X values, 6, 5, 14, 19. 19 what? Like what is it? I haven't given you any labels yet, right? And what about the Y values? 85, 87, 65, 64, 73. 73 what? Like what am I measuring here? Anybody want to take a stab at this? Let's talk about the Y values first. So I got 85, 87, 65, 64. What would be the label on my y-axis? Take a random guess. What is this data? What do you think it is? It's not height. Good guess. It's not temperature. Good guess. It could be, but it's not. Zach already knows what this is. Say again.
Seconds.
It's not seconds. It's not distance. All good guesses. All wrong. Huh? It's not units. It is grades. It's a final grade in a class. So this person got an 85%. This person got an 87%. Okay? So our y-axis is actually the final grade in a class. This is data from, I want to say 2 or 3 or 4 years ago that I grabbed from one of my math classes. Okay? So if the y-axis is their final grade, or their final percentage, what do you think the x-axis is? It's not the number of the student. That would be one way of identifying it. Like, this is student number 6, this is student number 5, this is student number 14. That's a good guess, but that's not what it is.
The number of students who got it.
Number of what?
Students who got the grade.
That's also a good guess, but that's not correct. Close. Good guess. Would that make sense, what Harmony just said? Like, if you get a lot of problems wrong, what's going to happen to your grade? It's going to go down. Is that kind of what is being exhibited here? Like, the more x gets larger, is the y going down? Like, look at student G over there, right? So you're very close, Harmony. It's not the number of errors. What else might cause a student's grade to go down? Absences. Thank you. That's exactly what this is. A few semesters ago, I keep attendance, and I went through every student, and I counted up how many times they were absent. Student A was absent 6 times. Student B was absent 5 times. And then I wanted to see, I wonder if there's a correlation between the number of absences and a student's final grade. Does it look like there's a correlation? Yeah, in general, what looks like is going on here?
The more times you attend class, the higher grade.
Yeah, the more times you attend class, so when absences are low, your grade is higher. The more times you miss class, your grade is lower. Okay? So, student G really stands out. What happened to student G? They missed 22 classes, and their final grade was 43%. What do you need to pass? 60. Student G did not pass my class, nor did student S, nor did student U. Okay? How about student Q? 100%, even though they missed 2 days of class. So is anybody kind of bucking the trend here? Who? R. What did R do? Missed 14 times and still managed an 89. Got a B instead of an A. Could have probably got an A. Wouldn't have missed those 14 times. I bet that student would have got an A. Okay? Now, am I giving you a grade on attendance? No. Okay? So, but you see the correlation? So, I wanted you to practice a little bit with Geogebra, but I'm also preaching at you, right? Like, I want you to come to class, and I'm trying to show to you that coming to class generally results in a higher grade. So let's say I wanted to finish this off and make this look pretty and make this look nice. Let's add labels to our axes. Because right now, if I just look, it's just a bunch of random dots. We don't even know what this means, right? So if I grab my pointer tool, and I just find some white space on my grid, I'm going to right-click on it, and it'll bring up this graphics menu. Notice if I wanted to shut my axes off, I could, but I'm going to leave them on. If I wanted to shut my grid off, I could, but I'm going to leave it on. Okay? I'm going to go all the way down to the graphics settings menu at the bottom, and it'll pull up this window. I'll make the window a little bit bigger for you to see here. And you can do a bunch of different stuff here, but I'm going to go to the x-axis, and underneath the x-axis tab, there's a label. See that? I'm going to label my x-axis. And what did we say it was going to be? Number of absences. Yeah, attendance is sort of correct, but that's a little vague, right? We would actually want to say it is the number of absences is what it is. Okay, and then I'm going to click on the y-axis tab, and we said that it was final grade percentage is my y-axis. And I'm going to close out of there. And now notice I have my labels on my Geogebra. And I would say I'm more or less done. I could make this prettier if I wanted to. Let's say I don't even care about the letters like A and B. What happens if I only wanted to see the dot? Like I'll go to point A, and if I right click on it, I can just turn the label off. And there, the A went away, but the point is still there. I just turned the label off. I could change the color. There's a lot of different things that I'm going to have you just experiment with as you start to do this. And depending on how picky you are about things, you can make it look pretty and do whatever you want. But I'm actually not going to have you save this one at all. This was just for practice, so you can scrap this if you want. I'm going to do a little practice with you on some homework problems that would appear in your textbook. Okay, remember we have 2 textbooks in this class, right? We're using that algebra one for its chapter 2 for the first 9 days of class. So I just grabbed a few homework problems out of the textbook that we're going to do with our computer. We'll talk about how we would do them by hand and how we would do them with our computer. So I'm back on this PowerPoint now. So this is a homework problem out of section 2.1 in that algebra. It says, solve the equation y in terms of x. So they give us this equation, 4x plus 2y equals 8. And the directions say, try to solve for that in terms, try to solve for y, meaning get y all by himself, right? If you were doing this on paper and pencil, I'm willing to bet most of you could tackle this. This is kind of 9th grade algebra stuff. I need to get y all by himself. So if I subtract 4x from both sides, I'd have 2y equals negative 4x plus 8. You guys agree there? And how do I get y by himself? Divide both sides by 2. So I would get y equals negative 2x plus 4. I have now solved for y. That would be the paper and pencil way of doing it, right? I want to see if we can do it with our computer. So open up your Geogebra. I'm going to scrap this. So I'm just going to go File, New. And I'm not even going to save that. I'm just going to get a new screen. Font size I'm going to make bigger. Okay, so I want this 4x plus 2y equals 8. I'm just going to go down to the input bar at the bottom, and I'm going to type it in. 4x plus 2y equals 8. And those of you that know what you're doing, know that that's going to make the shape of a line. It's a straight line. That equation is a straight line. Okay? Now notice what your Geogebra does right away. They simplified, they divided everything by 2 for you. See that? Divide by 2, divide by 2, divide by 2. They simplified it down. However, is that in the form that I wanted? I wanted to solve for y. That's what I was instructed to do on the homework problem. But that is not solved for y. But your computer can do it. Go ahead and over on the equation, right click on it, and notice you can change it to different forms. Well, look at that very first form. You guys recognize that from 8th grade. Y equals mx plus b. That's a standard slope-intercept form of a line, right? That's the one that solves for y. So if I click on it, it changes it into there. That's one out of about 1 billion examples of I can do it by hand with paper, or I can not even pick my pencil up and I can have my computer spit out the exact same thing that I tried to get by paper, right? Feel the 2 different ways of looking at that? I want you to get good at using calculators and computers and stuff to do menial tasks for you a little bit faster than long computation. Does that make sense? Okay, even though that's not long computation. Let's try another one. This problem says, find the distance between the 2 points. Find the distance between the 2 points. So, again, if we wanted to do this on paper, we could. My 2 points are negative 4, 1, and 3, negative 4. I could do that on paper. How would I do it on paper? Thoughts?
Is y2 over y1, or y2 minus y1 over x2. That's something like that.
I know what you're rattling off, Martin. What's he saying? He just did one of these to you guys. y2 minus y1 over x2 minus x1. Yeah, that's finding the slope of a line. That would find the slope of the line that connects those 2 points. Okay? So, Martin, I'm glad you said that, because I'm going to use you as an example. Martin at one point memorized a formula, and it was this. But as of this second, you weren't quite sure what that formula was for, right? We have what's called a slope formula. We have a midpoint formula. We have a distance formula. These are things that at some point you may have memorized, but you're like, oh, I can't remember which one is the midpoint formula, which one's the slope formula, which one's the distance formula. Do you see where I'm going with this memorized thing? Not that memorizing is bad, but it can get us in trouble if we're not exactly sure what we're doing. Okay, so yeah, this is if I wanted to find the slope. What formula would I use for finding the distance between 2 points? It's a formula called the distance formula. You might remember that one. Maybe you guys have memorized it. But again, let's just think about this logically. Okay, I'm going to get rid of this line that I had here. I'm done with this equation. Let's just graph negative 4, 1. So I'm going to plot the point. Negative 4, 1. And 3, negative 4. 3 comma negative 4. Okay, there's my 2 points. I want to know how far apart are they. If I drew a straight line, what's that distance? Now, if I was doing it on paper, what do you guys think? You guys might remember this one. I'm looking for this distance, right? But since it's kind of like, it's not straight, it goes across the grid, I can't just count the grid marks, right? But what I can count is from here to here, right? How many is that? 1, 2, 3, 4, 5. That's a distance of 5. And what I can count is this distance. 1, 2, 3, 4, 5, 6, 7. That's a distance of 7. Given that information, can you find the length of the hypotenuse? How? Yep, Pythagorean theorem. You guys just rattled off Pythagorean theorem. And Pythagorean theorem has actually been turned into what we call the distance formula. And where Martin was trying to go with that is x2 minus x1 squared, the distance of the x's squared, plus y2 minus y1 squared, and then take the square root of the whole darn thing. That's the distance formula. It's this big, awful, ugly formula, but all it is the Pythagorean theorem, is what it is, right? So it's going to end up being 5 squared plus 7 squared. So 5 squared plus 7 squared is, if I called this x, is going to equal x squared. 25 plus 49 is going to equal x squared. What does that add up to today? 74? And so my answer is going to end up being the square root of 74, which is what? 8.6 something? Okay? So, that's all paper and pencil shenanigans there. Let's just use our computer to help us do all of this. So, on your computer, do you guys see the little angle measure tool there? It's the fourth one from the right. Notice that this is a measurement tool. You can measure the size of an angle in degrees. You can measure distance, length, blah, blah, blah. I'm going to click on distance or length. And I want to just click on point A and point B and see how far apart they are. And sure enough, they are 8.6. It's the square root of 74 is what it is. Go ahead, Harmony.
Would you prefer the decimal method, or would you want us to leave it as for?
It doesn't matter. If you run into some kind of test or something like that, if it's multiple choice or something like that, but it doesn't matter. Yeah, you're never going to get something wrong for putting it in one form other than the other, unless the directions specifically say round to 2 decimal places or something like that.
Okay.
Yep.
So do like significant figures apply to this, or is it only what the directions say?
Pretty much what the directions say. Yeah, we're not getting too heavy into like statistics or anything. Good question though. Yep. So this spits out 8.6. We know it's actually 8.6 blah, 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 blah. It's an irrational number that goes on forever. So if you ever want to see more decimals, if you go to rounding, right now it's just set at if I go down to like 5 or 10, like let's say I go to 10 decimal places, now my answer is actually 8.60232566. You can see different rounding there. So again, cutting straight to the chase to find out the distance between 2 points is all I was trying to illustrate there. Let's look at one more here. Here, how about this one? Find the midpoint, -1, 1, and 7, -4. So I'm going to get out of this. -1, 1, and 7, -4. Okay? This time I'm not trying to find the distance in between 2 points. I'm trying to find the point that's right in the middle. It's going to end up being somewhere like right there. Right? Again, there's a formula for this. You take the two x's and you average them. Add them up, divide by 2. Take the two y's and you average them. So if I average the x's, it'd be 3. And if I average the y's, it'd be -1.5. I'm adding it up and dividing by 2. So my answer should be 3, -1.5. Okay? So it's going to be right there. But maybe I want my computer to do it. So I go to the new point tool. What do I want? I want the midpoint. So I click on midpoint. I click on A. I click on B. Sure enough, there's the midpoint. My computer spits out the midpoint for me. Right? Okay. I'm going to stop there. I'm going to give you guys your assignment that you're going to work on here. If you go to Blackboard under Course Docs and Links, you will see it says complete the following 2 GeoGebra tutorials and then take a snapshot of your finished tutorial showing all the green circles and then save it into your shared folder. So I'll show you here. Do you guys see the functions in graph 1 and 2? Click on that very first link, functions in graph 1. All this is a tutorial. Now you're going to do GeoGebra, but you're going to do it inside of this web page. So the GeoGebra application that's physically on your computer, that's not what we're doing here. We're doing it inside. It's the same thing, but it's in this web page, okay? Notice that this little tutorial has all these steps, and every time you successfully complete a step, it'll fill in the circle green. When you're done is when all of these dots are green. Okay, let's look at one together. Is everybody on the same one as mine? Some of them, this website got goofy and it opened up a different one for some people. Do you guys have the click anywhere in the graphics view and drag until you see the entire figure? Does anybody have that? Only one. Everybody else on a different one? Okay, this got really goofy this morning too when I was working with another group of students and I'm not sure why. Click out of it, close it, and go back to Blackboard and click on it again. Did it give you a different one this time? It says click anywhere in the graphics view and drag until you see the entire figure. And you should be able to drag, oh, look at that, it's a nice purple heart. You guys able to do that? Everybody there now? I don't know why you have to click out and click back in. I was really confused by that. It's something in Cyberland is going goofy with those links. Okay, you just successfully completed step number 1. It was just showing you how to move objects around. Notice you get a little trophy and a green dot, and you can go on to step number 2. And when you complete step number 2, you'll get a green trophy and a green dot, and you go on to step number 3 and step number 4, right? Some of these you'll be able to do in 2 seconds. Others of them you might have to hunt around for the tool. So it's like a treasure hunt is what this is. It's forcing you to try to find, the tool and the thing that's going to get you to successfully complete it. So what I want you to do when you're all done, when you have all green dots, I want you to take a snapshot of your screen. Now you could snapshot the entire screen if you want. I like to use this little Snip Tool. Anybody use that? It's awesome. If you go down to your window, I don't know if Macs have it, but if you go down to the window and you type in Snip, you can make a screen capture snip. So I can just do new snip and then I can highlight that and I just took a picture. So that's really cool. I don't care how you do it. I want you to take a snapshot of your screen and I want you to save it into your Math 107 shared folder so that I can go into your shared folder and verify that you actually completed the tutorial. That's what I'm doing. Then I'll give you a grade for completion. Okay? So a final snapshot should look something like this. See how this one has all filled in green circles? That's what I want to see in your shared folder. so that I can just go through and I can say, oh, Colby completed it, and I can punch in a completion grade for you. Any questions on that? Okay, so by the time you come back on Wednesday, you should have 2 of these, by the way, because you're going to do functions and graph number 1, snapshot it. Then you're going to go to functions and graph number 2, which is a second tutorial, do all of it, snapshot that one. So you should have 2 snapshots in your shared folder by the time you come back to class on Wednesday. And the other thing I want you to do by the time you come back to class on Wednesday is finish the syllabus quiz on Blackboard if you haven't done that yet. And probably go and finish that practice math quiz, that very first on the My Open Math, the 5-pointer. Get 5 out of 5 on that, so you should have darn near 100% by the time you come back on Wednesday. And then starting on Wednesday, we'll get going with more of the items that we're going to do in that algebra section 2, section 3, and so forth. So you guys got about 3 minutes left. Go ahead and work on this GeoGebra tutorial. If you're confident with where you're at, you're free to go. Have a great weekend, and I'll stick around and answer some questions for you guys on anything that you want before you take off here. Stop the recording. Okay.
Can you help me set this